This is going to be chapter 8, 6, and 7 of geometry, which is going to be the law of sines and cosines. I'm just going to kind of combine these together because they usually go together. This is basically how to apply sines and cosines to non-right triangles. So if you remember that SOHCAHTOA stuff we've been talking about in the last video, that was all dealing with you have a right triangle. Like you had to have a right triangle before you use any sine, cosine, tangent stuff because it only works for right triangles. This is going to be teaching us how to apply it to non-right triangles. So we'll start with the law of sines because it's the easy one. Law of sines is basically a ratio of the three characteristics. So it's usually written like this, and then I'll show you in a diagram. So let me actually draw a triangle here just so we have some reference. So here's a triangle. We'll call this angle A, angle B, angle C, and we'll call this side A, side B, and side C. So usually in a triangle, sides are declared based on their opposite angles. So if C is over here, the opposite side would be this one right here, so we call this lowercase c. So these letters are made intentionally. Lowercase a is opposite angle A, lowercase b is opposite angle B, and so on. So a law of sine says this. The length of side C, so we'll put C here, over the sine of the angle C is equal to the length of side A over the sine of angle A, put a capital A there because it's the angle, and length of side B over sine of angle B. So basically it says that if you take the side length and divide it by its sine of the angle that's opposite from it, that's going to be the same ratio for every single value here. And so usually we pick two of these to use and we cross multiply them to figure out one of the missing pieces in a triangle. So law of sines is pretty easy in terms of remembering it. It's just length over sine, length over sine, length over sine. Just remember that it's always the side and the angle that it's across from. So A across from A, B across from B, C across from C. Let me show you how we can apply this into a problem here. So we have a triangle here, and it says solve for the missing pieces of information. So the first thing I'm going to do is identify what pieces I'm missing. So I have side A here, so this 3 is lowercase a because it's across angle A. This right here would be side B, and this right here would be side C because this is across angle B, this is across angle C. Now, if I want to solve for a triangle, that means I need to get all three sides and all three angles. So I have one side here. I have two angles. So let's do the easy one right now and get this missing third angle. Because remember, solving means I have to have all three angles as well as all three sides. So I'm going to do my 180 trick because I already know two of the angles. So 180 minus first angle plus second angle. This should get me how big angle C is. So if we do that real quick here, 80 plus 45, and then 180 minus that, we get 55. So this angle is 55 degrees. So that's that done. So now we need to get my two missing sides here, and then it'll be all solved for. Now, obviously, I can't use Pythagorean theorem because it's not a right triangle, but I'm going to use law of sines to figure out these last two pieces. So I'm going to start with B here. So the first thing for law of sines is figure out which pair do you know. So in this case, I know the A pair. So I know this pair. This is going to be the pair I keep going back to solve the rest of the triangle. So I have the side A and I have the angle A. So that's what I mean by a matching pair. Because if you notice back here, we need the side length and the angle length to set up a fraction. It's kind of like similar triangles almost, if you remember the stuff from last chapter. So the side length over the sine of the angle is equal to, and then I pick whichever one I want to do. Let me do angle B here. So if I want to figure out side B, that means it'd be the side length of B over sine of angle B, which is 45. And then I would solve for B here by doing my cross multiplication. Now remember, sine of 45 and sine of 80, those are just numbers. This is nothing special here. So you plug sine of 80 into your calculator, you're going to get a decimal, and then again, it's just a single number. So what I tell people to do to avoid confusion is I shouldn't probably draw a line down there because we're going to cross multiply, which might add some confusion to some people. So we're just going to cross multiply here, but I'm going to do this first. Actually, I'm going to do this. I'm going to take this and get a single number out of it. So I'm going to go to my calculator and type in 3 divided by sine of 80 and get this decimal, 3.04627. Let me make that 28, make that 9 round the 7 up. 3.04628. 3.04628 is equal to B over sine of 45. Now again, make sure you're always in degree mode. So in this case, I am in degree mode. So make sure I did that before. So now, in order to figure out what b is, I'm simply going to times both sides by the sine of 45. So times here and times here. Because what happens here is that if I divide by the sine of 45 and multiply by the sine of 45, they go away. So I get b is equal to, and then whatever this is. So sine of 45 times this stuff here. So to make a shortcut, I'm just going to simply say answer, because this refers to what was previously the answer, which is what I got right here. And I get 2.15. So I know that side B is 2.15 units long. A 0.15. Okay? And then I can do the same thing to solve for side C, which I am going to do. So I would start with the same fraction, 3 over sine 80, because that's the pair that I knew at the very beginning. I could technically use this fraction now that I know what side B is. I could replace B with 2.15. But again, use the numbers they give you at the beginning. That way you know you're using the correct values. Sine of 55. Now we already know what this is going to come out to be. 3 over sine of 80 is going to be 3.04628 over, let's just figure out what this decimal is right here. What is sine of 55? Sine of 55, 0.8191, or 92 if I make that 5, round that up. So 0.8192. So then I'm going to multiply both sides by this value, 0.81 blah, 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 blah. That cancels out. 0.8192 on this side. Again, multiplying to get rid of the division. So dividing by 0.8192, multiply to get rid of that. So I'm going to be left with C here. And then in my calculator, take this times 3.04628. Oops, let me try that again. Sine of 55 times 3.04628. We get 2.4, that 9 is going to be rounded up, so it'll be 2.5. So angle C would be 2.5 units. And this makes sense because the rule, it's called the hinge theorem, but the rule in triangles is that if the angle is bigger than its side that's opposite, it should also be bigger. So if this is 80 degrees, that's the biggest angle in the bunch. That means that this side should be the biggest side in the bunch. And it is. 3 is bigger than both these numbers. 55 is the middle angle, and its side is the middle length between all three. And you can see that 55 and 45 are pretty close. They're only 10 degrees off. So their side lengths are also pretty close. So you can kind of use those inferences there to gauge whether your answers are on the right track or not. It's not going to necessarily check your work 100% accurately, but it should let you gauge on whether you're on the right track or not. And that's how you apply law of sines. So again, it's really just about setting up a fraction that you know, which for us was this pair right here, and then just setting up the other fraction and cross multiplying or getting it down to a decimal and going about your business. Again, very similar to solving similar triangles like we did in chapter 7, if you remember that stuff. So sometimes they won't give you a diagram, you have to make your own. So in this case, they'll say solve for NPQ if P is this, Q is this, and N is that. So what you want to do here is basically draw the triangle yourself because you want to be very careful on how you label stuff. So NPQ, so NPQ, says angle P is 42, so I'll put 42 here. Angle Q is 65. And then side N is 5. So you have to be very careful. You can't just put this anywhere. Side N means it's across angle N. So here's angle N. Across there means that's 5 right there. So just like in the last situation, the first thing we do is figure out this missing angle here, because that's going to be the easiest one to figure out first, because all you do is the 180 trick. So you do 180 minus the sum of the angles you currently have. And let's go ahead and figure out what that is. 180 minus 40 plus 65. 73. So this is 73 degrees. And then now we do the same thing we did last time. We get our pair fraction, which is this one right here. This fraction we can keep referring back to. So 5 over sine of 73 is equal to, and I just pick whichever one I want to do. So we'll call this little q. We'll call this little p. I'll do little q first, just because. So little q over sine of 65. Again, make sure you're taking the angle that's opposite the side length. And then we solve this out here. So I'm just going to do this all in the calculator to save some time. So 5 divided by sine of 73. And then I'm going to times that by the sine of 65. Just to get rid of the division over here, right? I get 4.74. So 4.74 is equal to Q. And then I set the same thing up for the next one. So 5 over sine of 73 is equal to, in this case, it's going to be little p over sine of 42. And this should be the smallest side because I'm using the smallest angle. So if we get the smallest side length, that means we know we're on the right track. So 5 divided, actually, let's just go back up here. 2. So that, and then times sine of 42. We get 3.5, which is good because that is going to be the smallest side. So 3.5 is equal to P, and those are my two missing side lengths. So I have all three side lengths now, and I have all three angles solved for, so that triangle is solved. So again, law of sines is the easiest one to apply, just because it's nice, short, sweet, and again, very similar to similar triangles, not to be redundant, that we did in the last chapter. You just have to make sure you remember to get that angle pair like here, N and side N. Make sure you get that single pair matched up. That way you can keep referring back to that for your problems. I'm actually going to skip over this one just because it's very similar to the ones we did, and the law of cosines is going to take a little bit longer to do than the law of sines, so I want to make sure I have time for that without overdoing the video too much. But again, as you'd see here, you'd solve for the missing third side. Then this would be your fraction pair after you know what angle E is, and you just do the same thing as last time. So, law of cosines. Law of cosines is a lot more complicated than law of sines. It's based off the Pythagorean theorem, so you can probably see some resemblance to the a squared plus b squared equals c squared business. It's still a way to relate the sides and the angles together without having a right triangle, and those are the three variations you see on your screen right now. So there's three different quote-unquote laws of cosines depending on which side you're looking for, but they all follow a similar pattern. So I'm about to tell you the pattern here, and again, it's going to sound confusing at first, but hopefully it'll sink in over time. So the way you remember law of cosines, it's the side you want, so in this case it's A, the side you want squared is equal to the sum of the squares of the other two sides, so B and C are the other two sides, you square them, you sum them, minus twice the product of the two other sides and the cosine of the angle across from the side you don't want. So it sounds like a mouthful. Let me try to phrase that a little bit differently now. So another way to think about it is if you want to use the law of cosines, find out which side you're missing and set up your equation as that missing side squared is equal to the sum, so adding the other two sides squareds, minus twice the product of the other two sides and the cosine of that angle. Well, so if you're looking with side A, you're going to use angle A. If you're looking with side B, you're going to use angle B. If you're working with side C, you're going to use angle C as your cosine angle. Now you might be saying, well, why would I ever use this instead of law of sines? Law of sines is so much easier. Well, it's because this will allow you to solve for situations that you can't use law of sines for. So for instance, let me show you a case where this would be used for. This one right here. So if I said, okay, solve for this triangle, and you want to use law of sines, well, you have a little bit of a pickle here because you don't have a key fraction, right? You don't have this fraction you can't use because you don't know how big this side is down here. You can't use the 6 because you don't know how big this angle is over here, and you can't use the 4 because you don't know how big this angle is over here. So there's no way to set up a law of sines here. So you have to use law of cosines. Now, usually the way this works is you use law of cosines once, and then once you've solved for that third side, then you can use law of sines again for the rest of the triangle. So usually you don't have to use law of cosines more than once, but there are cases where you have to use it first to get it out of the way, and then you're good to go. So let me show you how you use law of cosines here. So I'm going to call this side lowercase g, and here's how I'm going to do it. The side I want, so I want side g, so the side I want squared is equal to the sum of the other two sides squared. So 4 squared, 6 squared, the other two sides squared, summed, minus twice the product means multiply, product of the other two sides again, so 4 and 6. So notice how I use the same two sides in a row. 4 and 6, I square them, minus twice 4 and 6, I multiply them, times cosine of this angle. So if I'm using side G, that means I'm going to use angle G as my cosine angle because it's the only angle I have. So that's another indicator. It's the only angle I have, so I have to use it. And then you would solve this for G. So you go through this here. What you would do is you would use your calculator extensively. So G squared is equal to 4 squared, which is 16. 6 squared is 36 minus twice. Well, let me do this in my head here as much as I can. Come on. Come on. So minus, let's see here. 4 times 6 is 24 times 2 would be 48. So minus 48 times the cosine of 82. And then this is the point where I would use my calculator here. So G squared is equal to, I'm just going to type all this big mess here in. Making sure I'm still on degree mode. Okay. So 16 plus 36 minus 48 times cosine of 82. Make sure you put this last bit in parentheses if you're going to do this all in one go like I am, just so the calculator knows to multiply this together first. Usually it's pretty good about doing multiplication before addition and subtraction, but I'm always paranoid about that. And so we get 45.32 essentially. 45.3. People look at this and they say, okay, I'm done. It's 45.32 as the answer. And the answer is no, because that's what G squared is. So just like in Pythagorean theorem, you have to square root both sides now because you want the side length G, not G squared. So you do that, and then we go back to my calculator here. I'm going to square root this big mess. And 6.73 is the actual side length. 6.73. And that would be using law of cosines to find your missing side length. So now that you have that this is 6.73, now you can go back to using law of sines for the other two angles here. So now I have this here. This is my pairing. Now I can use law of sines to figure out what angle H and angle F are. Now we didn't use law of sines to figure out angles last time, so I want to finish out this triangle here. So I'm going to put a little bar here just to separate my work a little bit better. So let's say I'm going to call this, we'll just call this angle F and angle H. So let me say I want to solve for angle F first. So if I'm setting up for law of sines, I would do G, the side, divided by sine of G, the angle, which is 82, is equal to F, the side, which is 6, divided by F, the angle, which I don't know, so sine of F. So what I'm going to do here is the same thing as last time, sine of F. I'm going to figure out what this is here. So let's see what that big decimal is. 6.73, which I got from my previous problem using law of cosines. Sine of 82. 6.796. I'll do 7961. 6.7961. Now, if I want to solve for f, the first thing I have to do is get it out of the bottom, because right now it's in the denominator of a fraction, and I don't like that. So if your variable is in the denominator of a fraction and you want to get it out of there, you're going to multiply it. So what's going to happen here is kind of like, once again, back in similar triangles, or even back when we were solving sine stuff in right triangles sometimes. I'm going to basically take this bottom piece and swap it with my other side, which again is basically me multiplying both sides by sine of f. So multiply this side by sine of f, multiply this side by sine of f. This will cancel out and it's going to be moved over here, and then divide by 6.79 on both sides. But just to avoid all that, what you're really doing is just swapping out these two things here. So it's going to look like this. Sine of f is equal to 6 over 6.7961. And then you can do the inverse sine business. So inverse sine, and again, why am I using inverse sine? Well, because I want to figure out what the angle is, because this is an angle question. So just like with regular sine problems, if you want to figure out the angle, you're going to use the inverse sine, because that will cancel this out, and I'll be left with f is equal to the inverse sine of this mess here. So the inverse sine of that. Whoops, my bad. I forgot to type it in. Let me do that again. So the inverse sine of 6 divided by 6.7961. And we get the angle F is about essentially 62 degrees. Now, if you want a little bit of an easier version, you can always flip your fractions to have the angles on top and the sides on bottom. So if I did it like this, and I put the angle on top, so sine of 82, over the side length is equal to the angle over the side length, this is the exact same problem. If you solve this, you get the exact same answer. If you don't believe me, you can do it yourself. Um, so if you don't like your variable on the bottom, you can always flip it to the top at the very first. Just remember, if you do it for one, you have to do it for both. So if you put the angle on top for this one, you have to put the angle on top for the first one as well, and vice versa. So don't mix them just willy-nilly. Okay, you always have to be consistent with how you set your stuff up. So this is 62. And then to figure out what angle H is, I'm just going to use my 180 trick. So to figure out what angle H is, I would do 180 minus 82 plus 62. So you can type that into your calculator or do it yourself, and you get about 36, if I did it in my head correctly, which I think I did, but I'm just going to check. 36 or 35, maybe. 180. Brain's a little fuzzy at the moment. 180 minus 82 plus 62. Yeah, 36. So then that's triangle solved for. You have all three sides, and now you have all three angles too. Um, so again, you had to use law of cosines at the beginning to get what that side length is, and then you go back to the law of sines, and then if you can use the 180 trick to finish off your last angle. So again, a little bit more complicated, just one extra step there though, but you only have to use law of cosines once, which is good. Let's do, actually, yeah, let's do one more here. I was going to skip this one, but there's something that I want to show here, because this one's a little bit different than the others. So if we draw out this triangle here, and draw this out, we have A, B, C. So A, B, C. A is 5, so that means a side across from angle A. So that means that this is 5. B is 11, so that means down here is 11. And then C is 8, so over here is 8. Now, we have all three sides. We're missing all three angles, though. So this one's a little bit different than the last one in that we have all three sides, but we're missing every single angle. So like before, we can't use law of sines here. There's no way to use law of sines, because no matter what you set up, you're always going to have two missing values. So like before, we're going to use law of cosines. It doesn't matter which one we start with, so I'm going to start with the one that's alphabetical, which we're going to say is A here. So if I want to figure out what angle A is, I'm going to use my law of cosines. If I want to figure out what angle A is, I'm going to use side A. So it's going to look like this. The side squared, this is A, remember, so this is A. Side squared is equal to the other two sides, so 8 squared plus 11 squared, so this is B and C, minus twice the other sides, so B and C again, okay, so B and C again, times cosine of the missing angle that I want, which is angle A here. So you can use law of cosines to find out missing angles as well as missing side lengths. Just make sure if you want angle A, you're going to have side A by itself. So then you would go through as much as you can on your own. So 5 squared is 25, 8 squared is 64, 11 squared is 121, 8 times 11 is 88, 88 times 2 is 176. Again, my goal is to get A by itself, so I'm going to start eliminating as much as I can here. So 25, 64 plus 121 is going to be 185. Cosine of A. And then subtract this from both sides because I want to get A by itself. So I'm going to start eliminating stuff as I can. So it's going to be negative 160 is equal to negative 176 times the cosine of A. Then I'm going to divide by negative 176 to get rid of the multiplication here. So divide by that to get rid of that. Divide by negative 176. You get 0.90 repeating, so I'm going to put a little bar over there, is equal to cosine of A. Now again, if I want the angle inside, if I want that little answer inside there, I'm going to have to do the inverse cosine of this side and the inverse cosine of this side, because that will cancel out my cosine. Just like I did division to cancel out this multiplication, I did subtraction to cancel out this positive number here. I'm going to do the inverse cosine to cancel out the cosine over here. So I'm going to be left with angle A is equal to, and then I'm going to go ahead and do inverse cosine of 0.90. Whoops. I'm just going to type this in a bunch of times just so the calculator gets the idea that it's repeating. So not going crazy. I'm doing this for a reason. So that means that the calculator knows it's 0.909 repeating, and we get 24.62. 24.62 is how big that angle is. That's one angle down and the other two to go. So you might be saying, oh no, I have to do this 3 different times. And the answer is no. Like before, you use law of cosines once and you get this angle. Next, I would use the infinitely easier law of sines. So say I want to figure out what angle B is next. We'll go in alphabetical order here. I would use angle A and set up my fraction as before. I'm going to put the angle on top this time just to be easier about it. So I'm going to do, there we go. So I'm going to do angle on top. So sine of angle A, which is 24.62, over the side length of A, which is 5. 24.62, trying to get this right there, is equal to the sine of angle B divided by the side of B, which is 11. So again, you could always flip these around too. You could set up like this. Sine of 24.62 is equal to 11 over sine of B. So that's another way you could set it up, but I'd rather just set it up this way just because if I want to solve for a variable, I usually want it on top of the fraction, not on bottom. It just makes solving it a lot easier. So again, if you see if this is a little bit different than what we used to, that's the reason why. It's because I'm solving for the angle instead. So I'm going to have sine of B over 11 is equal to whatever this decimal is. So let's go ahead and do that here. Sine of 24.62 divided by 5, we get 0.0833. 833. And then since I'm dividing by 11, I'm going to end up multiplying by 11 to cancel that out. Multiply by 11 over here. Let's see what we get. Times 11. We get 0.9165. So 0.9165 is equal to the sine of B. And then since we're solving for an angle, we know it was coming. We use the inverse sine here to get rid of the sine function. And then whatever we do on one side, we repeat on the other. So inverse sine there. So we get B is equal to whatever that is there. So let's see. Inverse sine of 0.9165. And we get 66.42. And that's what angle B is. Now, we could do this again for angle C, but like before, if you're just one angle down, usually the 180 trick is better than not to use. So 180 minus the sum of the other two. And again, we are using this 180 trick because all the angles in a triangle have to add to 180. So if I know how many angles I have already with the other two, I know how big the third one needs to be to solve it. So I'm going to do 180 minus this sum, 24.62 plus 66.42. And we get 0.896, or not 0.896, but rather 88.96. 88.96, and that's your answer. So those are my 3 missing angles. So if you're missing an angle, it becomes a little bit more difficult because you have to remember that inverse trick, but it's the similar process. You use law of cosines once, then you use law of sines. Then if you want to use law of sines a third time to figure out or the second time to figure out the last angle, you can, or you can use the 180 trick. So again, don't think about these as memorizing a procedure. Think about them as memorizing not necessarily steps, but tools, I guess. So if you know how to work the law of cosines, and you know how to work the law of sines, and you know how to work your 180 trick and stuff like that, then you can tackle any problem of these types that I give you because it's just going to be a variation of mixing those steps together. So focus more on the smaller steps and getting those down than trying to figure out the overall, okay, this is what I do first, this is what I do second, this is what I do third. If you know how to use the law of sines, you know how to use the law of cosines, then you can just use them in any order you want or any order that will work once you're presented with a problem. So focus on the laws and making sure you know why and how they work, and the other stuff will come to you naturally. So that's it for this video. Again, let me know if you have any questions. Hopefully you enjoyed the video. Have a good day, night, or afternoon.